All right, it's 35, so let's get started. Noah, can you start the recording?
Yes, I just started recording, so we're good to go.
Oh, you already started? Okay, great.
Yeah,
Welcome everyone to a special event AHA speaker today. I am Oren, and I'm here to just help set the stage. Um, we currently are not in our typical webinar link, so if you just have any questions, put them in the chat and we'll respond to them uh, once we get to the Q&A section. I'll pass it off to Noah to introduce our speaker for today.
great, thanks. So hi everyone. Introducing Dr. Williams. Dr. Williams is an assistant professor of computer science at the University of Toronto with PhD appointments in statistics, psychology, economics, and a number of other fields. His lab work focuses on how we can take existing interfaces that we utilize every day and improve them to support physical health, mental health, education, charitable acts, and other areas. He's published, him and his group have published 85 papers, and they've been awarded awards such as Best Paper Award at Chi, and also the 1 million X Prize Competition Award for the future of experimentation. And so looking forward to just hear what Joseph has to share with us today, and hopefully there are a lot of great questions at the end of the talk.
Thanks so much for having me, everyone. I'm not sure where to look so it's most natural. I'll probably look at my slides and slightly up. So one thing I want to share before I begin is that I'm originally from Trinidad and Tobago in the Caribbean. So I tell people that because they say otherwise they miss what I'm saying trying to guess where I'm from. So you'll know I'm from Trinidad and Tobago, Caribbean islands, so I have your full attention. Let me know if anything comes up because the presenter tools, I'm not sure if it's completely moving in sync. It's not going to be intro, Noah. So the theme of what I want to discuss today is how do we use adaptive experimentation techniques to make everyday interfaces more intelligent? If you think about it, billions of people are using SMS or email every day. But often technology isn't changing our behavior for the better, it's changing it for the worse. How many of you were overjoyed by the messages you got this week? They made you healthier, they made you happier. What we try to do is take these everyday interfaces, just like text messaging or email, and try to turn them into intelligent interfaces that help people with health. For example, there's a global crisis in physical inactivity. Over 1.8 billion people every year at risk for avoidable diseases, which cost billions of dollars. If you think about mental health, right? Over 1 billion people suffer with mental diagnoses that may not be aware of, and they might lose about $1 trillion in lost productivity. And finally, think about formal and lifelong learning. We want to teach students, but now everyone has to be learning once they go into the workforce. So these are examples of behavior you want to change in the real world to have societal impact. So here's one example of how we do this, by reimagining experimentation. Think about experiments to help people to exercise more, to walk more steps. Option A1 might be, how would a walk make you feel better? Text back if or when you do one. But is there actually a better version of this message? What would message A2? When can you go for a walk today? Text back if or when you do one. And so this is a very simple idea, but the execution of it is what really matters. And what my lab focuses on is adaptive experimentation. How do we do something like turn a text message into an intelligent agent? And so to visually depict this, you can imagine taking text messaging, which we've done like we should for exercise above, and also mental health, and thinking, how do we generate different versions of that message? And that's where we rely on collaboration between LLMs, as well as scientists and practitioners and users. So we have a method of generating different versions. So that's intelligent because they keep trying new things. But then how do we figure out which ones are best? This is where we use AI in the form of reinforcement learning. And the key idea here is that we might start off assigning 50-50. But if we figure out that something's more likely, there's a 70% chance that message A2 is better. It gets you to walk more steps. So why do we give that more often? And the idea is we use these reinforcement learning algorithms to figure out what's the probability of something being helpful. And they give that to people more frequently. So over time, we might keep adding different versions and changing part of assignments. One might be 5% versus 55 versus 40, based on what's most likely to help. And we can keep testing over and over until eventually we might move towards what's best. But if you think about it, we never want to stop experimenting. And so even as we find what's most helpful, we might try to add new versions or we might try to personalize. And the idea here being, we might start at 50-50. Then we might discover that something, A1 is better for one group of people, like those who don't exercise much, and A2 is better for another group of people. So is it clear then how this kind of approach could also lead to personalization? So what I just gave you there was a bit of a microcosm of the entire approach. Let's take something as simple as text messaging and make it intelligent, because we can generate new versions using LLMs and people collaborating, and then use reinforcement learning to figure out which of those work where. So in terms of the promise of this work, we receive this $1 million X Prize for this being the future of experimentation, because our goal is to basically take everyday decisions and make them better by making it easier to do experiments and giving us better experiments. And we received this $3 million NSF grant, which is basically to give everyone else access to these tools: instructors, medical practitioners, scientists. Give you all a second to read that. So what motivates us is actually the limitations of current A/B testing and randomized controlled trials. So we all know that tech giants are using A/B testing to make billions of dollars. And scientists have used A/B experiments in the form of randomized controlled trials in controlled lab settings. But since 2005, I've conducted 500 of these real-world A/B experiments embedded in the field. As I pointed out earlier, they've been impacting in terms of personalizing learning, mental health, and exercise. But the problem is, it was still too slow. It's slow for data to help users, and for data to be used for the next experiment to figure out what we want to test next. And that slows down creating intelligent interfaces. The problem is that it's hard to design, deploy, and analyze good field experiments. Again, experimentation is simple, but some experiments you run, you'll be embarrassed to even try and publish. Some experiments win Nobel Prizes. So how do we make it easier for everyone to do high-quality experiments so they make better decisions in everyday technology? So when I talk about AI-accelerated adaptive A/B experimentation, I'm talking about adaptive experiments that analyze data automatically, like I hinted at earlier, so that users get better intervention more quickly, and scientists can test ideas in a greater number. And so I work on tools for designing experiments that will combine LLMs and human intelligence. So to do this kind of work, it requires publishing multiple disciplines: human-computer interaction in terms of designing tools and systems, applied AI, psychological theory, and the applied AI is interfaces for using LLMs and Gen AI, and then AI in terms of reinforcement learning algorithms, which also requires new techniques in statistics so we can analyze these algorithms to make sure they're actually reliable. And I'll talk today about applications in mental and physical health, as well as learning education. So that's a quick overview of today. The theme for this first part of the talk is how to make it easier to do adaptive experimentation. And I'll discuss tools for instructors to enhance explanations. And then second, how do we personalize messages to get people to exercise? And I'll point towards some of our future work, which are better algorithms and analysis techniques. I'll then think about how do we increase access to adaptive experiments? How do we allow people to run experiments when they've just got 10 participants or even one person that they're working with? So that's what I think of as qualitative A/B testing. And I'll also look at how we can actually personalize with small samples. So just taking mental well-being stories and personalizing them to someone and exactly what they're facing. And I'll close with one example of when we do this adaptive experimentation, what's the payoff? And if we actually design experiments right, we can actually find messages that are so powerful that in just a couple of minutes, telling students how to manage stress could actually boost their grades by 4%. Right, let's dive in. Part one. Tools for instructors to enhance explanations. So if you think about online homework, which we've all interacted with, often students get told an answer, but they don't get an explanation of why that answer is correct. And the right explanation can make a big difference. But now, if you want to be experimenting with explanations, a lot of instructors will complain, Joseph, I don't even have time to write one explanation. How am I going to write multiple experiments? So this is building on a theory of learning that I developed. And the idea behind this theory is when you explain why an answer is correct, it helps you learn, even if you just explain it out loud, because it forces you to see how that answer is an instance of a principle or pattern. So now the idea here is if we prompt people to explain why the answer is correct, they generate explanations. And then we can actually then add these in to show to other students. So the idea is we have a method now for continually generating new explanations. But if we have these explanations now, you wonder, how do we figure out which of them is actually helping learning? And that's, of course, where we do these adaptive experiments. We can figure out what's the probability this is helping, and we can give it more or less frequently. Does that make sense? So just to give you a quick schematic of what this looks like, right? So we use a reinforcement learning algorithm, like the multi-arm banded algorithm called posterior Thompson sampling, and it automatically analyzes data. And the idea is this. Let's assign intervention A1 or A2, like explanation A1 or A2, proportional to the probability that A1 gives the best outcome. For example, whether the user finds the explanation helpful or not. And so you can now actually realize, if we think of traditional experiments, they're almost like a prior belief. There's a 50% chance that explanation A1 or A2 is best, so let's give it 50% of the time. But as we get data from 10, 20 people, you might think there's actually a 30% chance that A1 will get the highest rating of being helpful, and a 70% chance of A2. So if there's a 70% chance A2 is most helpful, it gives the best outcome, let's assign to 70% of people. And is it clear how that way of changing probability of assignment can actually increase benefit to participants? But also, it can allow us to phase out less promising ideas more quickly so we can test other ideas. Scientists can run follow-up experiments. And you can see how we might go from 3070 to 2080, and it changes over time. Does that make sense in terms of the general schematic of how this works? So I'll just say it again to make sure it sinks in. The probability of assigning intervention A1 versus A2 is based on the probability the intervention leads to the best outcome. So you might start with 50-50 and you get some user data. You might update the probabilities to 30-70. There's a 30% chance A1 is best to give to 30% of people. Then you get more data. And at a certain point, you might actually add new versions. So you might get an idea from qualitative data, from an instructor, from a student, to say, here's another explanation we should try. And what's powerful here now is you can actually just change your probabilities. 5%, 55, 40. So you can actually add in a new idea with some probability while keeping the other one that seems promising. You get more data, and you modify these over time. Turns out the third explanation, there's a 73% chance it's best. Let's give it to 73% of people. And as you get more data, you can phase it in. Does that make sense to everyone, the process we're using, the kind of algorithm we're relying on?
There's a question actually from Zoom. It says, are the user data rankings or preferences something to change?
Yeah. In this particular setting, we're using quantitative information. So for example, the users would rate an explanation on a scale from 1 to 10.
Okay.
So then it's actually quantitative data because we're essentially using something that's a lot like the distribution you have like a z-test or a t-test,
Right.
but it's a Bayesian alternative. But there are ways to use things like preferences. Like there's multi-arm banded algorithms that focus, I think it's called dueling bandits. Thanks for letting me know. So I think people see the general schematic. I'll just give you some technical details. So again, this algorithm, posterior Thompson sampling, estimates the probability intervention is best. And there's many ways to do this. This is where the algorithm work and the statistical analysis comes in. But it's a multi-arm banded algorithm, one of the most fundamental forms of reinforcement learning. And in this case, we have a beta-Bernoulli Bayesian model. So just think of two arms, even a binary reward or outcome. So the set of interventions, like explanation A1 versus A2, you have the reward or outcome, like was the explanation helpful for your learning, yes or no? And you have the policy or the policy learning algorithm. What's the probability each of these being helpful? What's the probability of them being assigned? And so the basic Bayesian model here is essentially saying, let's actually have each of these explanations. The probability of them being helpful, getting a thumbs up, follows a beta distribution, parameters alpha and beta. And the idea now is that this models the probability that is helpful. So think of actually alpha as the number of successes and beta as the number of failures. So for every explanation, you've got, let's say, 5 thumbs up, 3 thumbs down. Another explanation might have 7 thumbs up, 2 thumbs down. And this basically helps you represent what's the probability this explanation will be rated as helpful. And so the Bernoulli likelihood function means that as you're getting data, you're updating this distribution. And so in a very intuitive way, you can rapidly get a sense of which explanations are helpful. And then these beta distributions, they're conjugate price and Bayesian inference. So they allow you to very quickly estimate the probability of each being optimal. So I know that was a lot of technical detail, but I put by that, I'm happy to answer more questions. But I think the key intuition people can understand, which is there are complex ways of computing these probabilities. And they're basically based on Bayesian analyses that are analogous to the things you might get in a z-test or t-test. So here's an example of one deployment we did. This was actually 3 Harvard instructors. And so what you're seeing on screen here is actually the dashboard that they could see. So they were testing a quantitative explanation for solving a problem against an analogical one. And so because of the way we chose the algorithm and used it, they could see the probability of explanation. At any point in time, there's a 23% chance of getting A1 versus 77% chance of A2. And what's helpful too is it's interpretable, right? They know what's happening each point in time, but they can also see why. So the mean student rating was a 7.26 versus 7.48. And that's based on 46 students versus 56. So what we found is instructors appreciated this because unlike some past deployments, they weren't just being told it was changing. They could see every point in time exactly how it's changing and what data this was based on. And I can talk about this later, but this actually allowed them to interact. If they thought that there was actually a misleading explanation, they could actually step in and change what it was optimizing for, or boost it with their own data. So what instructors appreciated was that this approach was giving student answers that are more helpful. The earlier ones can help improve the experience to later students. That's pretty neat. And one student quote was, "I assume companies are always A/B testing on me. At least the data I provide can help other people learn." So in addition to this qualitative information, what we did was actually run an experiment where we crowdsourced those explanations from students. And then we actually used the Thompson sampling algorithm to figure out which ones are better. So what you're seeing here on the vertical axis is accuracy increase. So we did a separate randomized experiment where we basically did a pretest. We tested people's knowledge of solving particular statistical problems. Then we actually gave them explanations or problems. Then we did a post-test. So the idea is we didn't just rely on their judgments. We actually showed how much could they increase their capacity to solve problems from pre to post. So what you're seeing here on the first bar is original problems. No explanations at all. And you see that they get a 3% increase in learning. But what you're seeing here now is the access explanations from the adaptive explanation improvement system. And what you're seeing here is these actually result in a 12% increase in learning from pre to post. And what's interesting is these explanations were crowdsourced from learners themselves. But once you actually ran it through the banded algorithm to figure out which ones are higher rated, we actually got explanations that were high enough they could boost learning. Now, you could be skeptical, right? You could say, well, isn't any explanation better than no explanation? So what you're seeing here in the third bar is the filtered out explanations. So these explanations from students that were filtered out because the banded algorithm gave them a low probability of assignment. So they were added in, but the algorithm identified them as being not very helpful, so they're filtered out. And what you can see is that these explanations are like getting nothing at all. So the algorithm really is doing useful work in terms of identifying better explanations and changing probability appropriately quickly. And finally, when you compare them to instructors' explanations, these are actually comparable statistically to the ones that were crowdsourced, and instructors actually found that what was identified were reasonable things that they would consider giving to their students. So this is clear how, by taking this approach, we're able to take crowdsourcing of explanations from students, generating actions, and then use this algorithm in a way that we can optimize and get better versions, which can then measurably increase learning. So to summarize that first part, we want to make adaptive experimentation easier to do. So here we developed tools for instructors to enhance explanations, which allowed us to crowdsource these better versions. And I elaborated a bit by showing we didn't just enhance explanations. I can talk more about how we enhanced messages to motivate students, questions we'd ask them to help them reflect, and also tips we would give them for strategies to use learning, like metacognitive strategies. So let's move on to personalizing messages for exercise. So the question here now is, how can adaptive experiments help personalize interventions for subgroups? And you can see this very intuitively here, right? Think of one group of people, like who might be low activity in green, high activity in orange. And instead of assigning properties on average, let's actually use properties different for different subgroups. For example, 55% chance of A1 for one group versus 45 for the other. And then for another group, there might be a 30% chance of A1 versus 70% chance of A2. So you can see how that can lead to personalization. So we look at this in the context of physical and mental health. So why I think this is such a powerful example is everyone can benefit from prompts to exercise more. Everyone can benefit from dealing with stress better. People feel sad, they feel anxious. But in this particular setting, we designed this also with a particular clinical population. Over 6 months, people get daily messages to walk more steps. And these are people who had comorbid diabetes and depression. So here's an example of the study. We're trying to figure out different messages for different people. So message A1 emphasized benefit. Doing more physical activity can help reduce feelings of fatigue. A2 mentions self-efficacy. You've made changes to your health before, we can do it again. And now we're going to look at people in orange. The orange group refers to low activity. They weren't really walking many steps in the previous weeks. High activity was they were actually walking above average, like getting out and about. So this is a lot of data. I'll give you all 10 seconds to look at it, then I'll walk it through. Okay, so what you see on the vertical axis is this reward or outcome, which is how many steps people walked. We're really interested in what activities or messages will drive this. And let's look actually at the first column, right? I'm not sure my pointer is showing up, but let me use the fancy laser pointer to emphasize. So what you're seeing is when you pull everyone together, right? If you don't even know or think about groups, what you see is on average, message A2 is better than A1, right? It's getting people to walk more steps. So now you can easily decide, I'm going to give actually A2 to everyone. But why would that be a problem? Well, actually break it up now into groups, right? So the green group are the high activity people, but they're only 20% of people. They're a statistical minority. So because they're a statistical minority, even though message A1 is actually better for them, you can't see that because it's washed out on average. So the problem here is that if we did traditional experiments, we might actually miss the fact that what's best on average is actually worse for a subgroup. So you'd actually be giving something worse to a statistical minority. Because in this case now, the first message talking about potential benefit is actually more effective for getting them to walk more steps. While the opposite is true for the orange group, the low activity, who are 80% of users, where now the message A2 is better than A1. Does that make sense to everyone how we're showing a scenario we identified where trying to give people what's best on average would actually be worse for a particular statistical minority? I also want to underscore that I think this problem is actually bigger when you're not using quantitative data. We can all think of times when we've taught and we'd say something a certain way, and because of a few comments, we think, okay, that's the best way to do it. The problem is when we're using data on average or from small samples, we're not continuing to collect data. We don't keep the experiment running long enough to figure out, on average, this is looking better, but there's a subgroup of people for whom this is actually worse. And again, this is the key part of this experimentation. When we assign 50-50, we don't just do it on average. We actually change it for subgroup. So for example, for the green group, high activity, there's a slight evidence where we give 55% of them message A1, 45% A2. Whereas for the orange group, there's actually pretty compelling. Only 30% get A1, 70% get A2. And this allows us to move towards personalization, where eventually people get what's best for them. To emphasize this, one of the things I think important about adaptive experiments is that we keep them running for longer because we're running them proportional to the probability something is better. So even when we have evidence something is better, we keep a few participants in the other group. And that allows us to actually discover things like what I just showed you. It allows us to discover that actually what's best on average is worse for a subgroup. So is it clear to everyone how this is an example where running adaptive experiments can actually figure out how to personalize messages by continuing to collect data in a way that isn't limited to either traditional experiments, or just making judgments based on qualitative data? To provide technical details of how this works, this is called a contextual Thompson sampling algorithm. And the key thing is we're estimating the probability of the best intervention based on subgroup, as I showed before. And here are the technical details. Basically, the way we do this is we actually fit a Bayesian linear regression. So the idea is you have a linear regression model that has terms for A1 and A2. What are they best on average? And then terms for actually, how does the effect of A1 or A2 depend on actually a subgroup? For example, people's level of activity. In the actual experiment, we actually include a range of subgroups. And the key idea here is that we use these normal inverse gamma priors, which you can think of as being equivalent to a rich regression penalty. But again, the key concept here is we fit a Bayesian linear regression. This allows us to actually model what the effects are on average, as well as the effects of different subgroups of people, and then allows us to compute these properties of assignment, like 50-50, 55-45, and so on. So what is the overall benefit of this? Well, we ideally would like to see that adapting messages using reinforced learning would actually lead to more steps walked. So as before, we ran another experiment. In the control arm, people would just get a message once a week to check in with them. In the random arm, we'd actually assign those messages, but they ought to have equal probability of assignment, like 50-50. And now in the adaptive arm, we'd actually use the full algorithm. So what you're seeing here is that from the first month to the sixth, we didn't see a sizable increase in how many steps people walk in the controller random, just about 25 more steps. From the adaptive arm, on average, people walk 600 steps more. So that was evidence that actually we can increase that step count, and that can have impact on their lifespan, someone with diabetes and depression, as well as their health span, how much healthier and better they feel. So in terms of one area of future work, especially with my two PhD students in statistics, is we've realized a lot of the algorithms that exist now, they haven't actually been evaluated in these kinds of contexts, education and health, as thoroughly as they should be. So what we're seeing is actually there are problems that arise where they actually can lead to false positives, where you believe something's better and it actually isn't. And so we're working on better algorithms and better statistical analyses. So some payoffs of this, which we showed in our X Prize win, is you can actually increase user outcomes by 8%, like I showed previously for education and for the exercise study. But also, we actually found ways to, at the same time, increase the probability of scientific discoveries by 4%. So it allows people to actually discover what's happening, what's working, what's the mechanism more quickly. Okay, so under this theme of adaptive experimentation for intelligent interfaces, I talked about easier adaptive experimentation. These tools for instructors to enhance explanations will be able to identify explanations that helped as much as those of a real instructor by crowdsourcing from students and figure out which are best. I also discussed how we can actually personalize messages for exercise, so we can actually increase step count by up to 600 steps over a 6-month period by figuring out what messages work for who. So let's move on to access adaptive experimentation. What I'm most excited about is every day we make decisions. Every text message we send, every email, everything we say outside of our mouth is a decision. How can we help people use adaptive experiments to think about those decisions, even when they don't have a big sample? Maybe they don't only have a couple people, maybe they only just have themselves to think it through. So let me talk first about qualitative A/B testing. This is the system we invented and we published at Kai. So you've got an interface that's as simple as a Google Doc, and you can call something like ChatGPT inside. Like, give me an email. We're all doing this, right? But here's what's nice. You do your editing, right? And you set create variation option. At a certain point, you're going to take part of your email and you click create a variation. Now, how do you do that? Well, here's where we allow you to actually access an LM in the middle. And in particular, we prompt people to use scientific knowledge in doing so. So the prompt here is, make this concrete using cognitive behavior therapy principles like positive affirmations for cognitive distortions. So we're guiding people to come up with LM prompts that actually then access scientific literature in rewriting messages. So the setting here is we're thinking of stories we can tell people how to deal with stress. So they call that LM option, and it generates an alternative version. Now, what's helpful here is I think this is a qualitative experiment because AI is helping you generate versions, either using scientific research, but people have the choice. And you can toggle back and forth. So you're thinking about this. If I think of my user, how would this land? A versus B. And a key idea here is that we want people to generate their own versions, right? So then we actually allow them to take a version and modify it. So now there's an A, B, and a C version. They can edit it. So once they've done that, what do? As you can see, they're able to toggle back and forth. And this is a very simple feature, but it's actually powerful because this kind of helps them see side by side, not just thinking out loud or thinking in conceptual terms. They can see and visualize how this might come across to someone. If they have an opportunity, they can also collect qualitative feedback from others. One key feature is that they can do the exact same thing on many other parts. So it really is a way of taking a piece of communication, like this story about managing stress, and breaking up into pieces where you can run these adaptive experiments qualitatively. A really nice feature too is when they previously used that modifier, like come up with a version based on cognitive therapy, that gets stored as a button on the side. So as they come up with modifiers, or we even like do prompt sourcing, they can click and apply those anywhere in the interface. So every insight you have, every AI prompt, now is something you can reuse in a different setting. Is it clear to everyone how this kind of tool helps people come up with content, create different versions using AI, reuse AI prompts, and think carefully about how it might land? So I can share more about details, but we found that AV Scribe was more usable and better for editing than a ChatGPT interface on average. But in particular, people found that actually it was better at helping them come up with more diverse versions. It helped them better express what they want to say, and that they actually were able to better get at versions that communicated ideas that thought would have impact. They also found that these AI prompts were helpful because they could reuse them. And all these together help them think more carefully about the comparisons. So that's our first step for access to adaptive experimentation. What I talked about there is developing tools that help people do these qualitative adaptive experiments where they can adapt the text they want to say, and they can compare them side by side in a way that can be useful for thinking how a message might land. I'm excited about this direction because building these into everyday tools, text messaging, email, or even high-stakes conversations, we can use AI to help people think, how do you say this differently? How would a scientist say this? How would a negotiator say this? How would someone with more empathy say this? So we can figure out exactly how this might land. And what we found is that even if they don't deploy the quantitative experiment, just this process tends to allow people to think through more carefully the decisions they're making every day. Just that process alone helps them be better at coming up with options. So let's move on to another element here. How can we apply this kind of adaptive experimentation approach in the sense of personalizing mental well-being stories, again, without large samples? So the theme we're thinking about here is personalizing mental well-being stories to a user's context. So the idea here is that we help a user share their circumstances. For example, those who are already down on themselves. They may have them share additional details in open-ended text. They down themselves because the many goals they set that they have not reached, like getting on the dean's list. They may have a prompt engineering framework, actually, that takes the user's input and combines it with actually narrative guidelines and past narratives we've built. So we built with clinical psychologists and communication specialists and HCI researchers examples of stories that help people manage stress. And we showed that these are quite impactful and helpful. But now we want to take those and make them directly relevant to what's happening for you right now. So that is, we take exactly what's on a user's mind at this moment, and we combine that with the past stories and the narrative guidelines we have of what might help manage stress. And then what's the output? It's a completely new, unique, personalized story from the LLM. Like, I had a hard time juggling academics and social life while feeling extra pressure. So I know it's a lot to read, but here's a concrete example. The user starts off with their context like feeling disappointed. We have the previous message from clinicians, the kind of thing that we created using techniques like the AB Scribe app I showed you. And they basically have examples of fixation, but then actually has principles for dealing with those moments and questions to reflect. Like, what simple true things do you sometimes lose sight of? And on the LM personalized message takes the current user's context, like mentioning Dean's a scholar. Then it actually gives a principle expressed in the way that the user wanted to receive. It's natural to feel lonely. And then basically gives them a question to reflect on. What kind of phrases can you say to yourself during moments of self-disapproval or disappointment? So I'm just showing you how it basically combines elements across all of these to give a better message, hopefully, to the user, one that's more fitted to their context. So here's a separate randomized experiment we ran. And what we found was that, on average, these LM personalized messages outperformed clinical messages. I was actually surprised by this because the clinician messages were pretty good. So what was better about these? Users reported it reduced their belief in negative thoughts more. Interestingly, it made the principles clearer to them, maybe because it was tailored to their context. And again, there were more useful reflection questions. And it's interesting to understand to what extent this is happening because it's directly in the user's context, or is it actually because the LLM now is accessing different scientific database? When you tell an LLM to use a particular set of research, we know it's got all the scientific articles in there. So might it actually be using that knowledge in a way that actually gives us better reflection questions than a clinician can think in the moment? So is it clear how these messages would take clinician stories that were already effective, take users' context, and put them together in a form that could actually help them by reducing belief in negative thoughts? So I think it's clear now how we use these techniques, adapting, experimenting in more qualitative ways to personalize mental well-being stories. I want to move to the impact. What's the benefit of speeding up this experimentation from decades to years or even months? What's the payoff of running all these fine-grained comparisons using tools like qualitative A/B testing? So here's an experiment that's one of the most impactful ever run in the last 20 years. This intervention message was sent to students before an exam. Think back to your first semester in school and having a test coming up and how it still brings, that fear to you, right, of how badly you could mess this up and how important it is. So what we told students was based on stress reappraisal theory. Being stressed during an exam can actually help you do better. Recent research suggests feeling anxious during a test can make you more alert and help you work harder. How will you use this during your test? And you can see how this combines many of our principles before, right? Thinking of a concrete explanation of the concept, giving them principles, helping them actually reflect upon it. We tested dozens of these messages. What we found is the right combination can actually have a lot of impact. So there was a 3-minute message that boosted grades by 4%, from a B to an A- at this school. That's what you can see at the control of this intervention. Now, what I find so interesting about this is I'm not even sure if telling them some of the answers could have helped them this much. If I told them the answer to the test a week or two before, they'd forget a lot about it. But somehow, by saying this concept, it sticks in their mind just the right way that when they come into the test I hypothesize instead of thinking about trying to get rid of their stress or push it away, they're accepting it. And then instead of spending resources trying to eliminate it, they're actually focusing on showing what they know, accessing what they've learned already, and applying appropriate strategies to solve problems. So to me, this is really nice to show the payoff by testing all these interventions, qualitatively using the AB Scribe tool, by thinking of ways to personalize them, by running large-scale experiments. This can all come together to actually have a pretty profound impact. These kind of almost magic words you can say to have impact on people in just a couple minutes. So what's our ongoing and future work? There are three themes I'm especially excited about. I mentioned the first one, which is more of the statistics and reinforcement learning theme of our research, where we want to have novel algorithms and statistics that accelerate discovery, help people more quickly so we can deploy experiments in the field, but also increase the probability of scientific discoveries. And this is where we really want usable algorithms. We ensure that most of these are things that actually people listening to this talk would actually want to go out and apply. Another key theme is using experimentation for prompt engineering. Every LLM, right? The prompt defines an LLM, a chatbot, an interface. So one example is a paper we've worked on, which is if you tell a chatbot to think about helping people manage stress, we might actually take every part of the prompt and experiment with it. Be a coach versus therapist. Ask lots of questions versus give suggestions. And the idea here is that this is an approach anyone can apply. Qualitatively or quantitatively, we basically randomize pieces of the prompt and then see the impact on how people interact with it. And I think that it's kind of a shame people aren't doing this. Everyone's prompt engineering, right? Whether they are aware of it or not. Are they showing fine-grained comparisons? Are they actually systematically thinking about what they did versus trying a bunch of stuff and then reporting out what's not really engineering or science, but more hearsay? I think this could actually have a big impact because everyone's a prompt engineer now, whether they know it or not. Finally, I've been thinking a lot about how we can have more impact. So what are shareable social media interventions? We know social media has such profound negative effects. And that's really tragic because they could bring people together. So how do we share social media for social good? How do we test out just the right words that you can say? So you've got healthy habit messages about exercise, about managing stress, about learning. And how do we produce these so they don't just have impact that we can measure scientifically, but they actually, people are dying to share them? How will we get people to be as excited about sharing things about managing stress or exercising as they are about sharing, cat videos or things that go viral? And I think just to have one connection, I was talking to Roz and others about, we have a paper on sleep bandits, sleep experimentation. I think what's really powerful is thinking of how do we help people experiment with the messages they can say to themselves and then share that with their friends? Because every time they send a message back and forth, it's like a ping pong ball. They're testing out message A1. They send to someone, they can try it out too. But there's also a nice connection where now they're actually together trying to experiment to figure out what do we say to ourselves or each other to help us build better sleep habits, help us actually get to sleep earlier. All these things we've been trying to do for so long, is this going to give us a framework figuring out how to actually figure out which ones have impact? And especially I think this element of passing things back and forth is cues to people and also gives them some accountability and a sense of connection. Does that make sense? These three themes, like these novel algorithms, trying to use experimentation on prompt engineering, qualitative and quantitative, and thinking about all of these interventions, we can think about how much we put them in social media formats where people can actually use social media for social good instead of the negative impacts.
There was a question from Andy about the, I guess, notion of having a control in these tests. If that's something that's also, I guess, to kind of analyze maybe case where you're not providing an intervention, but you're in certain patterns.
Yeah, thanks, Andy. Yes. So at a high level, I'll say you can basically include whatever you want in this framework. You can have control, you can have different options. And so, yes, you can. This is an example, we had a control group in the intervention. In some of those other settings, we had, just standard business as usual, like, try and exercise more. And so, yes, you can apply this to basically seeing when does what you propose be to control, as well as also trying to think, how do we improve on what's there? If we find something that's effective, why don't we kind of keep doing better and better? Because the ideal outcome is where, you get something that's better and that becomes a control for a future experiment.
Right.
And maybe that's something I can underscore, which is, I think the idea of trying to help people more quickly is a good one, right? But I think what I think is really novel here is this perpetual experimentation, right? So if you think of the text messages you get, if you think of a website, we should never stop experimenting, even from a scientific perspective as well, because we can probably find things that are better or things that are better in context. Like this might look better on average, but is there a subgroup for whom we can find an even better option?
Yeah.
Or do people change over time? Do they get bored of something or does it not shift?
Mm.
And I think for me, that's what's most exciting, right? Is that if we think of experimentation, if we want to make it not just a tool scientists use, but actually an engine for intelligent interfaces, we've got to make it so we never stop experimenting. It's easy to do, right? Don't even have to think about it. And also we do better experiments. They kind of combine practical insight from users and designers with insights from scientists. So I guess to summarize everything I covered, I started this vision, right, of adaptive experimentation for intelligent interfaces. And the first step here was let's make this easier. And I gave an example of tools for instructors to enhance explanations. And the highlights there were a dashboard instructors could see how explanations were being changed and adjusted in terms of the probability of assignment and what data that was based on, and how we could actually crowdsource ideas from students themselves by asking them to explain what they were learning. And that by using a theory of learning developed, we could actually give better explanations. But of course, those had to be experimented with adaptively to figure out which of those were more effective. And by following the right algorithm, we were actually able to get explanations that help learning just as much as those from a real instructor. We then talked about personalizing messages. So designing adaptive experiments that didn't just see what is best on average, but tried to figure out what might be best for a subgroup. An example there was, even if a message looked better on average of people, there was a subgroup who was a statistical minority, just 20% of participants. And by running adaptive experiment, we kept collecting data and changing part of the assignment differently for different groups, we were able to figure out actually what is best on average was actually worse for them. And so by finding the right options, we actually were able to help diabetes and depression walk more steps, up to 600 more steps after 6 months. I then thought about how do we give access to adaptive experimentation so anyone can actually make the interactions to an interface more intelligent. I mentioned this AV Scribe interface we invented and published at Kai, and how that could actually let you just take something as simple as a message or an email, use AI to generate different versions, especially clever AI prompts like, how do I use cognitive behavior therapy or particular scientific research in this context? Then people could write their own, and then people could write their own and compare them. And then people can write their own prompts and compare them side by side to see what the impact might be. A really interesting direction there, I think, is using this as a co-design tool. Anytime you have participatory design or co-design, could it actually help people to have this kind of tool that helps us compare them and use LMs to bridge different ideas we have? And the insight there was that people found this more useful in ChatGPT, but also better in terms of coming up with the diversity of ideas they actually wanted to test. And be able to use an insight about one AI prompt from one bit of text for another. I then give an example of personalizing mental well-being stories, where we could take messages from clinicians about how to manage stress, and then get a user to share their context, so we could actually adjust that message to exactly what they wanted to do in the moment. And we showed how that could actually reduce belief in negative thoughts and help them actually see the clearer principles and how they can apply them. And so I ended on this final example. What's the impact of this approach? Whether it's qualitative or quantitative, by running many of these experiments in months or years instead of decades, we're able to find just the right words. We explain to students how stress could actually help versus hurt them, help them actually go into an exam and do 4% better, where they're really able to show what they knew. Great, well, thank you so much, everyone, for your questions.
Yeah, and I think we have some more questions in the chat, and then we also, and then we also have some questions here. So maybe for people on Zoom, if they are, you can start with their questions. So this is from And I don't know, Ethan, do you want to unmute yourself? And maybe, see your question here. Or let's see, I think. I'll just get it. Well,
I can respond.
Okay.
Okay.
Here, yeah.
So I'll start. So Rod said, thanks to your provocative work. How do you see this applying within longitudinal interventions? Each person receives a series of prompts over, say, 6 to 12 weeks in condition A and a different setup in condition B. So in that setting, actually, I think I would consider actually running a different experiment. So you might want to compare A against B, which is fine. But I think that longitudinal ones are actually fantastic for this approach because let me be concrete. Like with the sleep experimentation we talked about, we might have people think, okay, today I'm going to try and go to sleep at 8 o'clock. And that might be A1, but A2 could actually be, today I'm going to try and go to sleep at 8:30. And so the idea here is that that's a setting where those mini experiments people run every day are really nice to experiment with because what works best one week might not work in another. Maybe actually for 1 week, going to sleep at 8 is a bit too aggressive and 8:30 is going to work better for them. Maybe once they figure out how to go to sleep at 8:30, they can push it up. So I think the idea here is that I would try and actually think about, can we run these kind of mini experiments or within experiments where we don't just think of the traditional randomized controlled trial where it's A against B, but we find lots of micro changes we can make and we can help people figure those out. So paper and Kai, it was called Sleep Bandits, like guided, flexible self-experiments for sleep, did actually try and take an approach like this. I think needs to go deeper, which is we give people lots of options. They try it out and then we'd actually give them some estimate of the probability that was actually helping. Does that make sense, Rod? I didn't quite answer your question directly, so I can elaborate a bit more, but I'm not sure if the piece about, can we actually think of small micro experiments we can run within those 6 to 12 weeks over time? Can we actually think of experiments where we can test those out on a smaller fine-grained level?
And then, Ethan's sheets. I think I can respond to that. So, okay. And then ask if I have any question here.
I have a question. Are we waiting for Ethan or?
So yeah, Ethan is unable to speak, but we can just answer. You can ask a question, I think, it's fine.
Okay. So I love this work. I think you mentioned something in ongoing and future work about prompt engineering, and I was curious about what you thinking, like comparing to other methods like text grab, where they're trying to do automatic differentiation through the text and that way trying to like optimize for the prompt engineering.
That's a good question. So I think those techniques, I don't think they rely as much on empirical outcomes, right? Like
So you have some sort of metric that you're trying to maximize, yeah.
But what's an example of how those methods? So an example of the experiment we ran would be, we have a short chat where people speak to for 5 minutes about stress, and we give instructions like, try to act as a coach or a therapist. And then experiment 2 would be, ask lots of questions with give suggestions. What's an example of how you think those methods would tackle that problem?
I think with those methods, you would need some sort of metric for how well that person is reacting to it, and then they would optimize based on that.
But would it optimize by basically generating different prompts, or what's the optimization process it would use?
Yeah, and the optimization, they end up making tweaks to the prompts, and then you can show it to the. I mean, you don't need a person in the loop. You can have your own metric for it, but I wonder if you could have a person in the loop. And I've tried them myself. I don't see them working really well, but yeah, I was curious.
So I think it sounds like, I don't think they're necessarily incompatible. I think they're doing a similar thing, right? You have a metric, or you should have several metrics, and you change different versions of the prompt or something else, right? To see how to optimize for it. What I suspect, if I were to think about them side by side, is that those methods have one metric, right? Like level of engagement. So they might be harder to combine different metrics like level of engagement plus whether people are getting a high quality response, plus whether they're, changing their negative thoughts. So I think one way that the experimentation helps, it allows you to set those, right? Like you can use as a human can set the different metrics. And I think also the way that they change the prompt, I'd be curious to understand, because each prompt is a different version, right? And so are they
Mhm.
tracking that in a way that we can then look at and see? Like, if you're a clinician, could you see, okay, you tried prompt A1, A2, A3. I think A3 had actually boosted up in some way. I give it to more people. So I think maybe part of this experimentation prompt engineering can be making those methods a bit clearer in terms of what they're actually doing and allowing people to interpret what's happening and then interact with it.
Yeah, that makes a lot of sense. So another thing that I wanted to mention is I recently built a framework for doing A/B testing, but with agents. So we're able to show them different like environments, and we can create counterfactuals for them to, um, act, and then we can like study their behavior and their responses based on that. And I think one interesting thing about agents is that you can show them A and B in all cases, right? They don't have memory. So I was curious about what you think about that.
Yeah, I think that's an example where LMs are really helping us supercharge this approach, right? Is that basically it's much easier to run these experiments, right, without the memory and comparing it side by side. And one thing I'm very interested in is if you think of our participants as precious, right, like students in a classroom or someone who has diabetes and depression, how can we actually run experiments with agents, right, constructing different profiles to figure out which of these things is most promising? So, for example, we don't have to run experiment 50-50, right? If you run some good work with agents, and then we think, okay, there's an 80% chance that this message is going to help someone with diabetes and depression to exercise, then actually you can deploy it like that. And the nice thing is you use the benefits of Bayesian inference. If you're right, we can go from 89% pretty quickly. But if you're wrong, we can learn that and we can slow it down. With, I think the big problem I see is we're often making deterministic decisions. Give this or don't give this. But we don't live in a deterministic world, right? Like I think Daniel Kahneman said, who won the Nobel Prize, we are deterministic creatures living in a probabilistic world. And the problem is we don't have the tools to help us make decisions, right? In proportion to how uncertain we are. So if you can do some nice work with agents to get us to say, well, I think there's an 8% chance this works, then we can actually efficiently deploy that, potentially give people what's better, but still actually be able to figure out, actually, it doesn't quite fit in this context. Does that resonate with you?
Yeah, thank you.
Thanks, Patty. I think I can respond to Ethan's question. Okay. Yeah, so Ethan's saying there's some difference between giving a student a fact versus using LM to provide care, looking after them. How do people feel about tuning their personalized messages to friends, like authenticity or humor and other things? Yeah, I think that's a really good question. And if you think about it, any kind of psychoeducation is some combination of facts and care, right? So we haven't looked at exactly how people design messages for others, right? We've looked at how people design messages, but they weren't necessary for a close friend. So the technique we used here was actually creating stories. So what we found is that if you give someone a story, it's actually very easy for them to see how it fits with them. So here's an example. Bob was, here's a story about Bob. Bob was really overwhelmed. Actually, I'll just show you. Okay, here's an example, right? What you're seeing in section 2 is the messages we came up with clinicians. So this is where clinicians work with human interaction researchers, with actually participants, with others. And the story would be something like, I just keep fixating on thinking about things I've done wrong. I start telling myself a few positive affirmations every day, like it's okay to make mistakes, it's natural to not feel happy all the time. Then prompt, what simple true things do you sometimes lose sight of? So this is an example where I don't think we directly ask people about how they would tune personalized messages to friends, because sometimes it's very hard for people on LM to know what's exactly going to make sense to that person then. So instead, what we tried to do was actually think about how can we help people share their experience? Like, I keep fixating on things I've done wrong, in a way that someone listening to that story could then actually apply to themselves. Does that make sense? So it's not like you're saying, yeah, it's natural to get things wrong. You're just saying, I remember times when I've been fixating on what I've done wrong. And the advantage of that is someone can hear that and think, there are times I've done that too. Or maybe actually think, I'm not fixating on what I've done wrong. I'm fixating on what other people have done that's caused a problem for me. So the idea is we're getting personalization by giving stories from one person's point of view, but making those stories concrete enough that other people can then actually apply it or change the principle to themselves. So what we found is that people who design these stories would often like express what they felt, but perhaps in a way that they could share with other people how it applied to them, like they could see the connection. And so I think what we found people really liked about this is that it felt authentic, like it was good to see other people go through similar kinds of issues. And in particular, being specific was helpful, like thinking about things I've done wrong. And so that in itself made them feel not that someone cared about them directly, but that other people kind of went through similar situations. So it wasn't necessarily that big a deal. They didn't feel as alone. And then authenticity could vary, though. What is interesting is we didn't actually find the LLM stories are better in terms of authenticity. There was a trend, but it wasn't there. But in terms of things like having concrete takeaways, they did do better. And in terms of things like helping people reflect. I think humor is not something we looked at, which actually could be a nice element. But maybe one thing people appreciated was balancing positivity with realistic struggle. So those are all things that like weren't necessarily personalized to the individual, but by giving someone's personal experience, they could see how to map it over. Like how to map being positive with actually realizing these things are hard. You may not always make progress right away. Does that make sense, Ethan, in terms of how we try to actually explore different ways of personalizing messages or stories to people? Okay, thanks, Ethan.
Also have a question. So I guess a number of questions, and again, thanks for coming to MIT and also giving this great talk to everyone here. It's just a lot of work with human interaction. So my question is around this stress enhancing intervention where you found that it was useful to give a message to students before their exam, and they were very important. I was just wondering kind of the process of how that intervention is found or discovered, and also I guess how long, and there are I guess several other questions. So what I mean by that is like what was sort of the proximal outcome that you guys were using to discern this was that intervention, and then how long does it typically take for the algorithm to kind of converge on a intervention? Because I imagine with Bayesian algorithms, you know, it could take some time for people to see scenarios, but that depends on the kind of number of interventions. So that's sort of like my first set of questions, and then the second set of questions around subgroups. Do you need to know a priori kind of these are the subgroups that we should run an algorithm parallel to, or is that can that be dealt with after the study has?
Yeah, let me start with the subgroup question first, right? So I just gave one example here of, you know, message A1 is A2 and then low and high activity.
Okay.
So what we actually can do is try to encode a number of different variables. So this is where we have this like Bayesian linear regression. So I think in the study, we actually used 7 different variables about context. So there's low and high activity. And then there were information about, you know, their demographics, how old they were. You know, other things like their level of exercise previously. And so I think back to this point about deterministic decisions versus probabilistic is when you include these things in a Bayesian regression, you don't necessarily have to make hard decisions like include age or don't include age. You can actually include those variables and then see if there's any signal that supports them. So there were things we just completely took out because the clinicians said, I don't think this matters that much. So 5% chance of matter, we just took it out. Because the more variables you have, the more data you need to figure it out, right? But I think this is a good example where you can include a range of variables and then you can see whether there's any signal that suggests we should optimize for those.
Okay.
Another thing that a good insight we got for designing these studies is a lot of the things that people talk about in the literature aren't always that effective, like age. We're sure age matters. But here's the thing, if you're 22 and I'm 25, that's just one data point, right? So what we found was really helpful is variables that change within you. For example, how active were you this week?
Yeah.
How active were you yesterday or today? That gives us a data point every single day of 6 months, right? 6 months times 30, right? 180 data points, because then we can actually figure out, oh, for you, actually, we want to adapt this today. Send you a benefit message or a self-efficacy message. So we found that's actually a variable that makes it a lot easier to do this kind of personalization, contextualization.
Yeah.
Check if there's a question. Thanks, Roz. Okay, so I guess I can get back to your other question, right? About
Yeah, because I also want to say
Okay,
the intervention, it seems to have found kind of what I think a lot of literature converging on the importance of synergistic mindsets. So the growth mindset plus transitive is helps people resilient. And I think if you end up utilizing a lot of different intervention texts, I think there's kind of converged on that. That was kind of interesting to see that the algorithm found that that was useful, or how that framework impacted the process and also just what the process. Be useful to know.
yes, exactly. I think this idea is about like the synergy of how things come together.
Yeah.
We're able to test more of these hypotheses, right? Because the classical approach is A against B, growth mindset or not.
Yeah.
And then you can try and combine them, which I think Dave Deeg and others have done. But we really want to make it easier for people to test many of these ideas to see how they combine in a particular context.
Yeah.
So I combine in context.
Right, exactly. And I guess how did you were they taking this exam? Were you giving them the kind of messages before or related to other prior exams, or how did you discern this is the best intervention for that?
Yeah, that's a great question. I think this is where, even though I started a lot on the quantitative experiments, right? I think the qualitative ones are honestly where adapting, experimenting has so much potential, because we all do this, right? So in this particular setting, let's put it here. Okay, so yeah, you can click on this link behind us to see use stress paper.
Yeah, you might read that.
But what we did is first we relied on several decades of research on stress reappraisal. So this idea that if you see stress as a potential thing that could help you versus hurt you, there could be some benefits to that. And I think the mechanisms, there are lots of hypotheses about that. But one hypothesis that I focused on in particular was that when you are stressed, you're trying to get rid of it. Like if you see stress as an impediment, you're like, I can't perform well unless I'm not stressed. And so then what are you doing? You're thinking about getting rid of stress, when what you want to think about is performing a task, right? How do I solve this problem? What knowledge is relevant? And so what we then did actually was go to that literature, design, even from the get-go, we designed like 10 different messages. Then actually I got on calls with people written those papers. And I kind of went through the messages with them, got their feedback, pros, cons, captured it like in a Google Doc kind of style, kind of like how AVScribe does, right? All AVScribe came after. And then we actually would do show it to instructors and students. So we had a way of doing lots of qualitative analysis, but the key thing I tried to do was, just like in the AVScribe setting, is the key thing for me is, I know it's simple, but kind of capturing these options and really keeping annotations, information about them, who said what they said, I thought was really helpful in terms of thinking through the trade-offs we had to make. And then we actually ran I think it was 6 different experiments. Sometimes we include a citation. Here's evidence that this stress thinking about stress as something can help you, not just hurt you, is helpful. We also varied a prompt. When would you apply this? Then we said, what's a note you can write to yourself? So the idea is that, like with synergistic mindsets, we bring ideas together. We're using cognitive psychology, we're using educational psychology, social psychology, affective science, and we're trying to think, what are all those elements, right? About how you think about it, how you set implementation intention that will get you to actually apply this. So you have a pretty broad design series, then we bring it together into like particular interventions and test those.
Yeah. This is a good point. And I have 2 more questions. I don't know, you probably so I guess I'm wondering kind of the design space of these interventions and what one can kind of influence, because in some sense, the intervention could be a nudge to particular behavior, but that person actually needs to do the behavior in order to benefit from the or we want to say that the intervention wasn't effective enough. So intervention to make so that person would be kind of
But I was just, I guess, partially curious about that because of, yeah, in our lab, we work with like a lot of wearable devices and sensors, and we would likely collect a lot of these outcome variables. But it seems like the interventions here are sort of around, maybe reframing once they think about the full task, as opposed to like changing it or tracking over several months. So I guess, yeah, I think I was just curious about how general is this kind of framework? Is it going to go beyond like text, or does it, yeah, or I suppose in your own practice, like, do you find that text is kind of the best medium to optimize a bandit?
Yeah, I think it's a question like how general is it and how to apply? I would say I think it's a very general framework because here's what you need: outcomes. Like for you, maybe that's actually be step count. You just need people like heart rate variability. You just find the outcomes.
Right.
Then there's basically options, right? Like action A, B, C, D, E.
Yeah.
So you can define that. And then there's contextual variables, which I think wearable sensing stuff is fantastic. Like I would love to do more work that actually we design interventions given those in mind.
Yeah.
I think that's very general. The text, it applies beyond text very broadly because you might even want to test like, program A versus program B, like a sequencing of, I think like Roz mentioned, a sequence of notifications over 6 weeks or 12. So you can test those things.
Yeah.
I mostly present the text because they're easy to understand. Like you can see right away like what the examples are, and then you can apply it to like, you can test different apps, right?
Yeah.
You can take a complex app interface and think about what's the component of this that actually does more prompting and coaching versus what's one that's more directive. So you can apply very broadly as long as you're clear on what the options are, what the context is, and then what the outcomes are trying to optimize for. One thing I would add too is I think that we think of this as kind of providing future-proofed research. One challenge I see is a lot of the experiments right now is that, and even algorithms, is they define the outcome in advance. And then if you suppose actually you think your outcome is not that great, suppose step count isn't such a good measure as actually people reporting that they're eating healthier because they've got diabetes. So the way we built our systems, like the framework, the one the X Prize, is so you can actually change those outcomes over time.
Okay.
So let's say you run an algorithm and you think, actually, outcome A and B, I want to actually combine C. You can do that.
I see.
Just like you can add different actions in. You can add more contextual data as well. So the idea is that it's like a living lab system. So you can always keep adjusting those things. Like it's meant to be useful to you, and you can make changes as you like.
And it's something I could go and look at. What is that?
That's right. Okay, it's called like the Arab Comp or Mooklet.
Okay.
So the papers are, but right now the grant to make it available is actually the Carnegie Mellon's hosting software.
Oh, okay.
So feel free to, I think it's John Stamper. You can also email John Stamper
Okay.
or Jeff Carver because I've asked them to host the software.
Okay, got it. And the final question was around sort of this notion of discovery. I think you mentioned that kind of at the end of the talk, and also kind of, and I was reading Susan Murphy's work, and it seems like after doing a bandit algorithm, it's possible that there are certain interventions that are still uncertain.
Yes.
And you might want to randomize. You alluded to this too. You might keep sort of certain actually converting them. Yeah, I was just curious if you could talk a bit more about the novel algorithms. I also have my own thoughts about what I feel like this area could benefit from. I told you I do a lot of also discovery.
Okay, nice.
So yeah, I was just curious how you were thinking about that.
Yes, that's a good point. Okay, so okay. I think that again, this theme of like there are things you want to be sure about. Like again, statistics, you really should never feel confident about anything, right? Like you found that A is even my stress results. 4% increase in grades. Okay. Would that replicate in another class? Would that change over time? Like if we tell students this over and over, maybe it actually gets less effective. We have to say something new. And also, is there some group of students for whom they need to hear something else? They need to hear like, it's okay that you're stressed. Here's how you dial it back. Right? So I think that's a good approach. We should always keep experimenting perpetually. Or more precisely, we should make it much easier to do than we do now.
Yeah.
So one of these algorithms actually is based on that. So I know that's a lot of technical detail, but here's the key idea. These bandit algorithms kind of estimate what's the probability this is the best option. Message A1 or A2.
Yeah.
And then you assign like 70-40. 70-30. But this approach actually says a traditional experiment does 50-50. So we call this like statistically reliable Thompson sampling, where epsilon of the time you assign with 50-50. So epsilon of the time you do a traditional experiment,
Yeah.
and then 1 minus epsilon you do the Thompson sampling.
I see.
So this is a hybrid approach where sometimes the traditional experiment gives you more reliable data, but sometimes it actually gives people things that are worse. So that is, we want to actually have a parameter that people can change for how often they do it.
Oh, I see.
So that's one example of a theme we've been looking at, is to combine them.
I see. And I guess thinking about this, are there considerations around, 'cause I think you mentioned about, wanting to maybe identify if there were effective interventions as early as possible. And thinking about this, usually with psychology and other fields to refine what the interventions could be. I guess my question is around the engagement challenge of getting someone to interact with the system enough. How I guess how detrimental is that? In addition of sort of this as well, it's like would add more interactions with the intervention to actually understand the discovery, just basically discover something, because you're also operating on a case where you can potentially port this to a new set of people, and also achieve some kind of understanding of what's a so. But my question is around: are there any kind of sample size limitations or considerations when you're doing these kinds of studies? Just because it all seems like one could work observational data to also learn something that can be start for the system. I'm just curious about how much time it might take, if there's a way the observational data can.
So I guess I'll frame the question as basically, how could you use observational data to help these decisions? And then how do you make considerations around sample sizes?
Yeah.
So yeah, I think the key process is always, what's the probability of A1 being better than A2 on this metric for this subgroup of people?
Yeah.
So I think that if you have observational data and shed light on that, then that's definitely very useful. And that's a kind of unified framework, right?
Yeah.
You can run one of these algorithms or another model fitting process on your observational data and see how you change your probabilities. In terms of sample size considerations, I think that one thing to consider is, because of this Bayesian framework, you can integrate across small sample sizes. In our XPRIZE work, we actually had some classes at 20 people, some had 60. And that was okay, because even though it's underpowered from a classical perspective, you're not going to do a hypothesis and expect to think it's different or not. We then integrate that data. Because 10, 20 participants gives you a slightly higher mean. And we can then actually pull out the data from other classes.
Yeah.
So the sample size considerations are broad in the sense of you can collect data across many small studies, which is again a technique that's used in medical field as well. And so the consideration for you to ask yourself is, how much data effort is the data to collect, and how useful is it to just change the uncertainty slightly for you?
I see. Okay.
Because that's a decision you all can make, right? Is it worth running 20 people or 100? If they're available, sure. But if they're a lot of work to collect, then it won't reduce your uncertainty so much.
Okay. Yeah. I guess the question runs more around the time, how many time points or how many interactions is what I need to get a more robust estimate of the intervention. Yeah, it just isn't on average or just from your prior work. I'm just curious how much time.
Yeah, I think that actually you need, right?
Yeah.
That's you also have to answer that in context. I think that some of the tools of traditional power analysis can be useful.
Okay.
So for example, if your traditional power analysis says a difference of 0.1, accuracy can be 40% versus 50%, would require 300 observations to detect 80% power.
Yeah.
Then that's some evidence that actually need a bigger sample size for this. Now you may actually be okay with running it if it's 150 observations, because you don't need to make 80% sure. You can pool data and that's okay with you, right? You can adjust probability. But I think that's actually, the truth of analysis actually can be quite useful for understanding all that.
I see. Okay.
I do a power analysis and it actually will always, the things of power analytics are definitely correlated with what this would be useful for.
I see. Okay. Yeah, and the reason I'm asking these questions are to kind of like, maybe like you have some historical data, there's you go to sleep, for instance, and the amount of hours that you get, and maybe you're also collecting your mood data, and so if you have variability kind of on both things, it'd be feasible for one to learn what a good, maybe not a policy. Ultimately, maybe the question is like, what's the minimum amount of sleep that I can get in order to feel happy? When should I sleep? Feel the most happy on the next day, what have you. And it's possible that the interacting with a system like yours, one could do experiments and then report their happiness the following day, which might take a certain amount of time. But there's also that data that they have and they've been collected in the past. And so I was just curious about the on a person specific kind of scenario, like which time. Wondering. And I also had like an idea to pitch to you, but it seems like we're at the end of this session. I was looking online to see, that's here. Oh yeah, I think here, yeah. Yes. Siri, yeah. Siri, you don't have any questions? Yeah. Safety. And, really got great. And I also asked Warren Lee to see if